Hi, we are going to discuss how to graph absolute value functions. The parent absolute value function is the graph that looks like this. So the equation is y equals absolute value of x. If you make a table of values and you pick numbers -3, -2, -1, 0, 1, 2, 3, then for each value you find its absolute value. And so for positive numbers it's pretty straightforward. It's going to be the same numbers. Absolute value of 0 is 0. The absolute value of -1 is 1. This one's going to be 2 and this one's going to be 3. This is how we get this graph. This point here is called the vertex, which has which is where the function is going to be at its absolute minimum. And it's got this axis of symmetry which is going to pass through the vertex. And in this case the graph opens up. So we're going to rely on knowledge of this graph and also its any transformation that we may have to sketch the graphs when something else is there, in addition to just absolute value of x. The domain of this function is going to be all real numbers, and the range as it is here is going to be from 0 to infinity. So this equation, f of x equals the absolute value of x minus 2, since minus 2 is outside of the absolute value, this is going to be shift 2 units down. So we are going to take the graph that we just saw and shift everything down 2 units. So the point 0, 0 is going to move down here, point 1, 1 is going to go down here, point 2, 2 down here, 3, 3 there. And the same thing is going to happen on the other side. And then I'm hoping you're using a ruler for drawing straight lines. So we are going to sketch this part here. And we are going to sketch this part here. It's supposed to look like a V regardless of what kind of types of transformations you are going to have here. Okay. Next graph, next equation is going to be f of x equals absolute value of x minus 2 minus 3. This minus 2 here will be responsible for shifting the graph 2 units to the right, and that's going to be our first step. First, shift 2 units to the right. And then the second step is going to be this, down 3. So shift 3 units down. Again, we are going to rely on knowing what the graph of absolute value of x looks like, and we will perform the same steps with every point. So the vertex 0, 0, shift 2 units to the right and 3 down. Another point is going to be here at 1, 1. That point gets shifted 2 units to the right, 3 down. Point 2, 2, 3 units to the right, 2 down. What am I missing? Missing one more point. 1, 1, 2 units to the right, 3 down. 2, 2, 3 units to the right, 2 down. 2, 2, you're going to go 2 units to the right, 3 down. So these are the points. And then on the other side, it's going to go like that, but we are going to focus on the location of the vertex primarily, because from the vertex we're going to know what to do, because it's just going to be going up from there or down with both rays that make it up. And then the graph's going to look like this. Now we have -2 times the absolute value of x plus 5. We have 3 things happening here. First of all, we multiply the absolute value of 2. That's a number that's going to be greater than 1, so it's going to be vertical stretch, meaning vertical stretch with a factor of 2. And that means we are going to multiply our y values by 2. The negative in front of it means we're going to flip it over the y-axis, the x-axis, so reflect over the x-axis, and after that this is a vertical shift 5 units up. So let's see what's going to happen here. Take 0, 0. Vertical stretch doesn't apply to it. It's still going to stay at the origin. Reflector over the x-axis doesn't apply to that either. And then we're going to shift it 5 units up. 1, 2, 3, 4, 5. By the way, I do want to point out that the negative here indicates that the V is going to go like that. So expect the graph to have that type of shape. Our other point is 1, 1. We're going to stretch it vertically by a factor of 2, so 1 gets multiplied by 1, it gives us 2. Reflected about the y-axis gives us negative 2. And 5 units up is going to be 1, 2, 3, 4, 5. Next point is 2, 2. Stretch it by a factor of 2 gives us 4. Reflected about the x-axis is going to give us negative 4. And 5 units up, 1, 2, 3, 4, 5. You can see the pattern. It's going to be 1, 2, 1, 2. And then the other side, since the graph is symmetric, you are going to be able to do the same thing. So you can see this graph appears to be narrower. This is because it's vertically stretched. And we are going to connect our dots. Be very careful when you do it, so it looks nice and pretty. And this is the graph. So I do want to point out here that while the domain has not changed, the range of this function is going to flip, because now it goes to negative infinity. So it's going to be from negative infinity and all the way up to its maximum value, which is at 5. So that's what the range here is going to look like. The range ultimately is going to be tied to the location of the vertex. Right. Next problem. 4 times the absolute value of x minus 2 minus 1. So what happens here, there are 3 things. The first thing is going to be, we start from x. Minus 2 here is going to be a shift 2 units to the right. The second step is going to be stretch but with a factor of 4, vertical stretch. And the third step is going to be shifting it 1 unit down. Down 1 unit. Okay, so we start with from 0, 0. First it gets shifted 2 units to the right. Then we're going to multiply it by a factor of 4, which nothing's going to happen to it. And then down 1 unit. We're going to take 1, 1. Shift it 2 units to the right. Multiply it by 4. Shift it down 1 unit. So 1, 1. Again, we're going to stretch it. So we're going to move it to the right 2 units. Multiply it by a factor of 4. So 1 gives you 4. And then 1 unit down. Point 2, 2. You're going to shift it 2 units to the right. Vertical stretch gives us, by a factor of 4, will give us 8. And we're going to go 1 unit down. That's going to give us 7. And then you can plot the other points. Sorry, not this one. This one here. And this one. It's always helpful to use symmetry for graphs that are symmetric. And we connect our dots. So this graph appears even more narrow because you have even a bigger stretch factor here. The range here, since we have a low point, which is at 2, negative 1, it's going to be from negative 1 to infinity, since it opens up. Got one more. Negative the absolute value of x minus 3 minus 1. This is going to be responsible for shifting it 3 units to the right. It's the first step. 3 units to the right. This negative here is going to be responsible for reflecting at about the x-axis. And this minus here is going to be responsible for shifting it 1 unit down. 1 unit down. So we know because this is negative, our V is going to open down. So what do we have? We take 0, 0, shift it 3 units to the right, reflector about the x-axis, that's going to keep it in place, and then move it 1 unit down. It gives us this point. 1, 1, shift it 3 units, 1, 2, 3 units to the right, reflect it, and then shift it 1 unit down. 2, 2, 3 units to the right, reflect about the x-axis, 1 unit down. And then you can repeat that same process here, because once you know where the vertex is, everything else is going to be symmetric about that. One part is we're going to have our other part, and that's what we have, and we should be able to identify the range here. As since it goes down, it's going to be from negative infinity to the vertex, which is going to be to the y coordinate of the vertex, which is at negative 1. And that's all there is to it.